My name is Jalil Jackson. This is going to be my project demonstration for FMR, standing for Filter Map Reduce, which is just a CLI tool that applies symbol transformations to CSV files. And so these are the commands here. If we actually show that in the terminal, that's what comes up when you look for the documentation for FMR. And so first I'll be going over the motivations for the project. So basically I wanted to do this project in order to learn Go, or I am learning Golang. And so I knew this project would force me to understand how to parse and manipulate data with Go, which I think is really important whenever you're trying to learn a new programming language. And then yeah, I also just wanted to feel the power of Golang because the data that I was using to test is actually has a million rows. So if we look into the data directory, I generated a file. I'll call it test.csv. So if we look at the contents of test.csv, we see it's a lot of data in there. It's actually a million rows, which is something I generated using this Python file, basically just generating a bunch of random information. And it's a million records within that CSV file. So the reason I chose so many files is because when using a lot of tools in production, they need to be a lot more scalable because you're dealing with larger data, and so the demands on the performance of those tools needs to kind of withstand that environment. And so, any tool that you wanted to build in Python, I don't know if it could bode well under a million or more records of something. I don't know if it could parse a million or more rows of something as efficiently as it can in Golang. So I just want to be able to kind of see and experience firsthand the kind of power of a lower language like Golang. All of my projects thus far have been in Python, which is a lot more of a, it's a dynamic interpreted language. And it's a lot more high level, a lot more abstract, where something as Golang, even though it's not as low level as C, is definitely more low level than Python. And it kind of forces you to understand things like pointers, stack versus heap, runtime and compile time, and just more so memory management, even though there is a garbage collector in C, it definitely isn't as loosey-goosey as Python. So that's why I wanted to build this project and build this project in Golang. And so one of the other things I wanted to mention is that I tried to experiment with distributed data processing because I know one of the main advantages of Golang is its ability to do concurrency a lot easier than other languages. But in my benchmark testing, I actually found that the distributed processing version of the functions were slower, sometimes as much as twice as slow, versus just kind of following the sequential programming model. And so I would like to admit that this is probably due to my inexperience dealing with concurrency in Go, namely things like Go routines and channels and mutexes. But, I will continue to experiment, research, and improve that skill set in the future. Or, it could have also been, you don't necessarily see the advantages of distributed data processing at, the level of scalability like a million records. Maybe I needed, to experiment with 10 million records or 100 million or even a billion records to see the advantages of that. But unfortunately, due to the limitations on my, my computing power, I'm just using a laptop for this. So, a million records is kind of as large as I was able to go with this context and these tools. But I will continue to, in my next project, I will be using, Go routines, channels, and mutexes, basically concurrency. But yeah, you guys will see that in the future. But let's get into demoing the project. So I provided some test commands. So as you can see, and if you're unfamiliar with the Unix piping functionality, I'll go over it super quickly. So in this data directory, we have the test.csv file that I generated. If we wanted to see the content of this file and print it to the terminal, we would do something like that. I did that earlier. That's just basically printing the output to the terminal. But if we wanted to pipe that output into another like program or another basically another program, we would do something like this, and this is a Unix pipe, and so we're piping it into something else. So if I wanted to pipe test.csv into another file, let's call it test2.csv. If we look at the terminal now, we see that we have two files. So we test our cat test2.csv, we see it has the same exact data. So I'm going to remove test2, test2.csv. And yeah, so we're back to that. But so yeah, basically this command that I provided is just a test command using the test.csv file. And so I'll explain what this is doing. So we're taking the output of test.csv, we're piping it into FMR, the CLI tool that I made, filter map reduce. And this command specifically is basically just filtering the indexes. So we're saying we're taking test.csv and the indexes between 100 and 1,000. So actually, I'm going to show you guys what that does. But yeah, if I were to just run this, it would print it to standard out in the terminal. And we see, it's kind of hard to see here, but basically these are the records between index 100 and 1,000. So if we go to, or actually we didn't pipe it to a file, but let's say if we were to pipe it to a file called test.csv, and then looked at test.csv, we can see that we have those records here. And so yeah, it's 900 records because obviously 1,000 minus 100 is 900. But I wanted to show that we still keep the follow the rules of CSV file, even though we index between or we take the indexes between 100 and 1,000, we still append the header of the file back at the top, just so that if we wanted to take test.csv and pipe it into another filter map or reduce command, we could do that. So yeah, I'll get rid of test.csv, and then we'll just run, oops, not that. And then we'll run that command. So basically we are taking this, we're piping test.csv into this command, taking the indexes between 100 and 1,000, and then piping that again into the program itself. And this is a map command. Basically, it is mapping certain values of one column into something else. So this one is multiplying the orders column into 11. And of course, we have, we have built-in edge case handling for things like, well, what if this isn't, integers? What if it's not a numeric column? How do you multiply things that is not a numeric column? So we obviously have checks for that. Taking the data types and ensuring that the commands that you're running on those data types make sense. So in here, we're filtering 100 1,000, piping that into the program, and we're multiplying every value in the orders column by 11, and then we're saving that to a file, destination.csv. So if we run this, nothing will print here, but if we look, we have des.csv. If we were to cat that, we have the data there. And yeah, so that's, one example. I provided another command to show the reducing functionality of it. And basically what reducing does is, instead of, resulting in a CSV, we're resulting in a simpler kind of a statistic. So I'll just show what that means. But if I were to print stack, not that. If I were to print that command, what this is doing is we're catting a test.csv, we're taking the output, and we're basically only filtering between things in the total spend column, our values in the total spend column that are greater than or equal to 5,000. So our only values greater than or equal to 5,000. Actually, I'm just going to show that here again. But yeah, once we run this command, it'll print it to the terminal. But here in the total spend column, all the values are greater than 5,000. And I just did that to show that the command really works. But yeah, so if we were to pipe this again and find the mean of the column total spent, and we print that, what you'll see is that it prints out the mean of total spent. So if we were to do something else, if we were to say the mode, basically which value appears the most, that would work too. So 5,907.88 appears 8 times. So this would be the mode of the total spent column after filtering for values greater than 5,000. So yeah, that's another example of a command that you could run with FMR. yes, that was a project demonstration. Please let me know any feedback or thoughts or critiques or maybe even compliments or anything like that. But thank you guys for watching the video, and I'll see you guys next time.